Yeah, my sound is all clear, right? Well, it's 6 o'clock. Thank you all for your patience. And well, let's get started. Ladies and gentlemen, distinguished decision makers, and our students, good evening. Welcome to the JR Academy Leading Edge Showcase. I'm really glad to be here as your host. My name is Catherine, and I'm the account manager of JR Academy. Firstly, please allow us to appreciate this distinguished guest. We are honored by your presence and would love to extend the warmest welcome to you. Secondly, I would like to take a few minutes of your time to briefly introduce our company, JR Academy. Well, JR Academy is one of the largest IT organizations in Australia with 34,000 registered members. We use our exclusive learning system to be an IT community for people to have more chances to get employment opportunities. We really appreciate that there are already more than 8,000 students choose us and got a job offer. Well, we host a wide range of professional IT training bootcamps that stretch across the majority of aspects of the IT industry. So to help people to improve their technical skills and competencies, and also make it easier for them to be employed. In today's showcase, there are 6 full-stack Agile groups, and they are ready to present their most innovative projects and outstanding technical skills. Each team will get their 10 minutes project seminar in order, and once all the team finish their seminars, they will enter the team breakout rooms and wait for our guests to come in and have more detailed discussion with them. Now, we declare that the showcase is commencing. So let's warmly welcome our first team, Team Sigma, to present their project. At the meantime, Team 2, ProEats, please get ready.
Hey, good evening, everyone. This is Team Sigma, and my name is Aaron, one of the developers of the project. It's a great honor to be the first team to present and introduce our project. So let's get started with a video which includes a detailed introduction of Sigma.
Hello, everyone. This is Maggie from Project Sigma. We're very glad to bring you our OAP system. OAP is a software as a service application with 2 front-end systems for company admins and job candidates, respectively. Our service is providing millions of question sets and online assessments, through which employers and job hunters can interact effectively and efficiently. So, the recruitment process will be extremely simplified. Next, let's see our tech stack. To develop our backend server, we use Gradle as a fast automation build tool and Java Springboot to develop RESTful APIs along with the Swagger documentation. We also use Hibernate for object relational mapping and Flyway for database version control on PostgreSQL. On the 2 front ends, we use Typescript and React to enable static coding and fast rendering. We also develop responsive web pages by end design to fit in any size of user screens. For the admin system, we develop out-of-box functions by Omni.js to handle complicated routes and logic. While for the assessment system, we use native React Router and Redux to keep it lightweight. For architect, our DevOps team has deployed the front end to AWS S3 and used the CloudFront to speed up the global delivery of our web contents. While the backend has been deployed to ECS Fargate in private subnets with auto-scaling tests. Particularly, we have set up an end-to-end monitoring platform by Prometheus and Grafana, and we have set up a centralized logging platform by ELK. With such deployment, while keeping our application with lower latency, higher availability, stronger security, and better performance. Next, my teammate Aaron will demonstrate our application.
So here's how our Sigma assessment application works. For new users to start, simply click Sign Up link on the login page. Then enter your email, password, and your email verification code to proceed to next step. If your company has already been registered before, simply enter some keywords and your company will pop up in the drop-down list. Or you can simply type your company name if it hasn't been created before. You will need to enter your company details if you want to create your company. Next, you will also need to input your user details, including name, job title, mobile number, etc. Mobile verification code is implemented to finalize the sign-up process. After successfully sign up, you can log in with your email and password or mobile and verification code to our dashboard. You'll see a dashboard homepage section, question set section, assessment section, and the profile management section. You're able to create your own private question sets of your company. Or you can either use free question set on our platform or even purchase paid question set from others. In the question set section, you can view a full list of all your question sets. By clicking the Add button, a pop-up window will allow you to create new question set by entering the question set name and description. You will be able to click into a selected question set to view the details and also create questions for it. You can define multiple types of questions. Simply click Save after you have entered all the details of the questions. Once you have a question set of your company, you will be able to send it to your candidates as an assessment. Simply go to Assessment section and click Create. In the pop-up model, you can set some more details of the assessment, including the assessment name, a selected question set, time period, number of the questions, and all other details of the assessment. You can review the details of your assessment on the right-hand side before you click Submit. You can also review all your assessment details by clicking into a specific assessment from the list. Here, you can also send your assessment to your candidates. You can either invite your candidates by email and send it to a list of your candidates, or create a public link including the QR code and share it on social media or anywhere else to promote your company. Anyone who scanned the QR code or click the link you shared will be able to take the question set. Candidates who receive the link via email will be able to access the assessment and start to enter the questions defined in the question set. Candidates who access the assessment via QR code or public link will need to sign up and log in before they can take the test. We also provide a profile management section for users to view and update their profile, change their mobile number and password. So this is a Sigma assessment platform. With millions of questions, you can know your candidates better than ever and simplify your recruitment process.
Okay, thank you for watching. And if you're interested in our project or team members, you're more than welcome to head to our breakout room afterwards to have a chat with us. Thank you.
Thank you, Team Sigma, for your performances. Well, now let's welcome Team 2, ProEats, and at the meantime, Team 3, Braincell, please get ready.
So, hi everyone. I'm Sam, the team lead from ProEats. Today, we are thrilled to present you with our project, and we will be covering 3 parts. Today, we'll be covering 3 parts in this presentation. First, I will show you a demo video. This is the same video in the brochure for today's showcase. Since you probably have seen it, made it shorter and the pace will be really fast. And I will stop halfway and talk you through the rest of our stacks and architecture. And in case you want to watch the entire video, there's a link in the brochure, and you can find it also on the board to your left-hand side. So let's get into it.
Hi everyone, I'm Sam from ProEats. As a foodie, one of my favorite things is to eat out and discover new restaurants. And today, I'm gonna show you how to eat like a pro with ProEats. This is how it works. Open ProEats website. You will see a collection of featured restaurants sorted by cuisine and rating. Also, you can search for state, party size, and cuisine to get a list of restaurants that best match your needs and filter through them to find the ideal one. Dive into one of the top-rated restaurants. The clean and simple design makes it easy to read through all their info and reviews. You can zoom in and out on the map to see the exact location of the restaurant. On the booking section, select your party size, preferred date, and time to find out all their seating options. To make a reservation, you must sign in or sign up if you don't have an account. You must also provide the correct email and password. After you sign in, the information will be pre-filled. Simply fill the rest and make the reservation. You will receive a confirmation email within seconds. And there you go. You have secured a table for your party ahead of time. In your profile page, you can see all your upcoming and past reservations, alongside your saved restaurants and account info. You can cancel a reservation at any time. Once your reservation has been completed, you can leave a review, rate your experience, write some comments, use a nickname if you feel more comfortable. You can only submit 1 review per reservation. If you really enjoy the experience, you can save the restaurant for easier access, and you can find your review on the restaurant page. For our business partners, go to the bottom of the page and log in to see your dashboard. Managing your reservation has never been easier. You can see all the details in the reservation section. You can complete or cancel the reservation with a simple click. If you wonder who built this amazing website, we are a team of 13, including 8 developers, 4 DevOps, and 1 business analyst. We implemented the Agile methodology in our daily development. Here are some of the stacks we use in our frontend and backend.
So I will stop here and come back for our technical stacks. So for our front-end, we use the basic 3, JavaScript, CSS, and HTML with React framework. We use Redux toolkit to shorten the development process instead of the traditional Redux because it has too much boilerplate to set up. We also know we know how to use it, but there is a better way to increase our productivity. So why not? For our styles, we started with Sass and Material UI. And later on, we introduced the Styed-Component because of the style pollution to prevent that. And we also used the Pixie.js for our flow map visualization, which is not fully developed. Here's a screenshot of it. And the idea is that the restaurant owner, they can draw their own flow map and assign the reservation to each table. We also use the JEST and Typescript for both front-end and back-end to test and prevent errors. And it does take a lot of time to figure out the types at first. And sometimes it's really time-consuming and frustrating to do so. But when you get used to it, it's really worth the time. For our backend, we implemented the REST API in Node environment with Expressjs. We used Sendgrid for sending the confirmation email. And finally, we use MongoDB as our database with Mongoose library to handle data manipulation. That's pretty much all about the stacks and why we choose them. Now, let's hear from our DevOps Vivian to tell you more about our architecture.
Hi, everyone. This is Vivian. I will introduce the architecture of this project. In this project, we use the three-tier architecture, consists of the presentation layer, business logic layer, and the data storage layer. Let's look at the presentation layer first. For the presentation layer, we configure the AWS S3 and CloudFront. The Route 53 is used to manage the domain name and route users to the app. We use S3 bucket to host our React static website as the front-end solution. We use CloudFront to configure CDN for loading page, which decrease the latency to deliver contents to the users. We also register the SSL certificate on AWS Certificate Manager to improve user experience. For the logic layer, our application is implemented as ECS Fargate tasks in 2 different availability zones, which provides high availability and deployed in private subnets for secure communication. The private subnet does not have direct access to the internet. Therefore, we attached 2 NAT gateways in public subnets to solve this problem. The NAT gateway can talk to the internet on behalf of the ECS so that the tasks are able to request the ECR images or send logs to the Cloudwatch. Then we deploy the application load balancer to allow traffic from public to reach our containers so that users can access the ECS through application load balancer and forward the request traffic to the container tasks. Each Fargate task is attached to an elastic networking interface. Then the IP of the networking interface is added to the load balancer configuration. This architecture allows our application container to be safely isolated from the rest of the internet. They can initiate communication with external resources through NAT gateways and still be able to receive traffic from the public through application load balancer. For the pictures uploading feature, we use Lambda function and API gateway to implement. API gateway can provide a secure and a scalable gateway for web APIs that route HTTP requests to Lambda function. The use of Lambda function benefits from the serverless architecture, which reduces the problem of server latency. The data storage layer was implemented using MongoDB. Our project used Cloudwatch and Grafana for monitoring and alerting. The application load balancer and Fargate sent logs to Cloudwatch and then imported into Grafana. Next, I will talk more about the CI/CD pipeline of this project. So the Bitbucket pipeline is used for both front and back. Pipeline will be triggered when the code is merged to the main branch. Then the Bitbucket pipeline will look for this YAML file to execute the pipeline steps. For the front end, after the pipeline is successfully installed and built, the build artifacts will be uploaded and deployed to the AWS S3 bucket. And then the CloudFront will be set up to deliver the web contents to the users. For the backend, the pipeline will first install the packages, Dockerize the backend, and then push the images to ECR. The ECS Fargate tasks will be created to deploy the backend by using the latest Docker images. Well, that's all about the architecture. And now back to the Sam.
Thanks, Vivian. That would be everything for our presentation. If you're interested, we welcome you to join our private room later. We have prepared another presentation in which you can interact with, and I will be introducing our team members individually, including their responsibility and contributions to this project, so you can get to know them better. Thank you again for your time, and we'll see you later.
Thank you, Team ProEats. Thank you for your wonderful performances. Now let's welcome Team Braincell for your presentation. Now on, Team 4, please get ready.
Oh, can you see my screen? Okay. Hi everyone, we are Team 3 Braincell and I'm Jacqueline. Our product is Quick Learner. So in the beginning, I have to say we have a really lovely team. Consists of 2 tutors, 1 BA for DevOps and 9 developers. And also we have 5 excellent teachers during the process to support us. So everyone wants to learn different and everyone wants to learn interesting. That's why we start Quick Learner. Quick Learner is an online quiz website where users can create quiz and share with their friends. So we are trying to provide users with an easier and quicker way to start learning. So up to now, we have complicated most features and I will go through with you later. And in the future, we will have data visualization and share quiz by link. So to start with, you can log in or sign up or log in with Google to create accounts. And as long as you have entered in the dashboard, user can edit their information in setting areas. To create a quiz, user can upload the cover they want and fill some basic information about this quiz. And then user can choose the topics related to this quiz. And for the questions, we have 2 options, the multiple choice and filling in the blank. User can add the options and set the correct answers and save the questions. And after insert all the questions, user can publish this quiz. And then user can view this quiz in My Quiz section. As long as the quiz is generated, it will generate a unique code and it can be shared to everyone to enter this code. And besides, user can also find the quiz in Explore sections. They can use the filter bar to find the quiz they want to join and choose open the timer or not and start the quiz. So after finish all the questions, user can submit this quiz and we will show the correct answer and the accurate rate in this screen. And when back to the home page, user can find the commit histories and his recent activities. And next, I will hand to Hannah to introduce more about our team.
Thanks, Jacqueline. Hello, everyone. I'm Hannah, and I will introduce you how we manage the project and cooperate with team members. In this project, we use Jira to implement Agile methodology with a Scrum framework to deliver increments. And we also created a product backlog and a wish list of tasks that need to be prioritized in this project. Our team broke down complete items on the wish list into 8 small, more easily manageable sprints to ensure each smaller goal could be accomplished. Eventually, we completed 95% of the tasks in each sprint. Specifically, in the first sprint, we spent a whole week practicing code conflict in case making any severe mistakes in future work. And because our team members' entry ability is different from each other, we use pair programming well during the whole development process, and it led to team cohesion and better code quality and productivity. Every team member has a strong sense of responsibility and can schedule, organize, and coordinate projects in high efficiency and with a teamwork spirit. Additionally, we attend daily stand-up meetings actively and self-reflected on our work during every retrospective meeting on Monday. As shown in this cumulative flow diagram, under our effective and close cooperation, we can see that our team had completed 90% of the features as we planned. Some features are still in progress and testing, and we will also add more features to create a better user experience. For example, we would love to add a community to our platform, that our users create their quiz groups, share links or code within the groups, and create posts and comments inside the community module to build an active community with our platform. In the next part, Witty will introduce you to the technique we used in this project.
Thank you, Hannah. Hi, everyone. I'm Witty. I will introduce the skill stack implemented in our project. We choose the MERN stack to develop our project with many advantages. As we know, MERN stands for MongoDB, Express, React, and Node.js. They offer opportunities for developers to build full-stack applications with an attractive interface for users to interact with. which enables the users to navigate through pages and respond to actions smoothly and quickly. It also makes our team more agile, allowing team to iterate quicker on new ideas and software change. On this basis, many technicals used in this project, specifically such as the Redux, materials UI, and responsive design for front end, in the back end, such as Swagger for the API documentation and the Mongoose for data manipulation. The key features we choose technicals and tools is efficiency, cooperation, and the scalability. About efficiency, for example, we choose Moon to build the project so team can use JavaScript both front end and back end. We use Redux to manage our application state and choose Redux toolkit, which makes it easier to write good Redux application and speed up development. For the cooperation, for example, with the Swagger API tool, the front end and back end can communicate easier, which can provide better teamwork. As for scalability, by using MongoDB, which is a NoSQL database, we can extend the business in the future if we want. And thanks to the React component-based development, as well as the RESTful style API, the business can scale when growing rapidly. In the next section, Grace will introduce the DevOps part in our project. Thank you.
Great. Hi, my name is Grace. I'll be introducing the DevOps part of our project. We implemented a single region 3-tier architecture for the website. The content of the application layer has been delivered to S3 and has been accelerated through CloudFront. We mainly use ECS Fargate for our logical layer. And for the rest, we deploy Lambda functions with the serverless architecture to achieve. We use ECS because it is more cost efficient compared to EC2 and sufficient for our current workload. We plan to switch to EC2 if the user traffic grows later. To ensure availability, an auto-scaling policy has been applied so that it will be auto-scale when the memory utilization reaches a certain benchmark. We chose ECS also because it is secured, with all containers launched in a virtual private cloud with isolated secure networking. We set a security group for ECS service that only allows the request from the load balancer so that the task container cannot be accessed through its public IP. To further improve it, we can try applying private subnets and net gateway to make the backend more secured. According to the 4 golden signal theory, we ran an instance for Grafana, which received the Cloudwatch logs for the backend. Also, an OpenSearch cluster has been implemented to analyze the VPC logs. For the pipelines, we chose CodePipeline as the CI/CD tool. For the front-end pipeline, we use YAML file to install packages and build the application. The build artifacts will be deployed on S3 as a static host web page. For backend pipelines, we use Dockerfile and YAML file to Dockerize the backend and create a Docker image. Push it to ECR, then code deploy will initialize new cluster services on ECS based on the updated task definition. We also implemented our pipelines on Jenkins for more practice and to get familiar with different CI/CD tools. For data security and confidentiality, we store the credentials in code build as environment variables that can only be accessed by our team members to prevent confidential leaks. In the future, we plan to better protect our data using server-side encryption tools such as AWS Key Management Service. We also use Terraform in our project. As an IAC tool, it helps us to modulate different parts in our infrastructure in a form of code. And we divided them into 9 modules so that we can share them within the team. We try to create the modules as small and functional as possible for them to be reusable. And for simplicity, we integrated all IAM roles and security groups in the modules that really needed them instead of making them individuals. That's what we've done so far, and it is still a preliminary setup. There's definitely more that we want to keep working on. During the time we worked on this project, we cooperated by setting IAM roles for our members
to manage the cloud resources on one AWS account. Our DevOps team will set goals for every week and have stand-up meetings every day to set and assign tasks. We also share our new learnings and help each other with the problems encountered. We also have weekly meetings corresponding to the different stages of the Agile methodology with the developers, business analysts, and our tutors to track the progress of our project, to understand new product requirements, and we adapt our plans to the requirements from the developers. This is all for our project and how we achieved it. Thank you all for listening, and we are Team Braincell. I would like to invite all of you here to come to our team room later, and we're open to any questions, and I really hope you to come and find out more about us. Thank you.
Thank you. Thanks so much. Thank you, Braincell. Well, now let's welcome Team 4, Lifesaver. Well, at the meantime, Team 5, Omni, please get ready.
Hello, everyone. My name is Rayling, and we are Team Lifesaver. And it is a pleasure to introduce our project HomePlus to you guys. There will be 3 parts in this presentation, and I will firstly give a brief introduction about our project, and Rex will give a demonstration to walk through our website, and Colin will introduce the tech stack we use, and lastly, DevOps will introduce the deployment of our website. Okay, so let's start. In our team, we mainly have 5 developers and 4 DevOps, and Rex is our team leader. HomePlus is a customer-to-customer platform, which allows posters to post their tasks on the platform, and then tasker can search for the tasks from our website. Posters are able to post tasks and set budget for their tasks. And they also can accept, reject, cancel offers from the taskers. Taskers are able to search proper tasks and send an offer to the poster. And here is our workflow, and we will demonstrate it more in the next section. And our tasker is our main reference website. And now Rex will demonstrate our website to you.
Hi, my name is Rex, and in the next 5 minutes, I will introduce to you how this application works. So on the homepage, you can see there are 2 buttons, which you can post your task for free, or you can become a tasker. When we scroll down a little bit, we can see here is the steps, and describe your task, set your budget, and choose the best tasker for you. So now we assume there is a user called Kevin, and Kevin want to post a task. And so Kevin just the end of his lease and want to find a cleaner for his house. So we just feed in the end of lease. And choose the day for the task. And set a date, certain time of day. And before we type in any budget, we can just clear this. And we'll want us to key in budget. And also we need to fill out any other information required. So the house information and continue. The system will ask us to log in. After we log in, we can just continue our post. And just type in anything. Submit. And this post has been done. So when we switch to other category, we can see here in the second step, we need to provide different information for this certain category. And next, I want to show you how a tasker make an offer. So when we switch to our tasker site and get into this browse page, we can see here's the map and with a search bar and a filter. On the search bar, we can just search clean. Here's the result. So after that, when we use the filter, we reset it and we can use different category or different site range. Also, we can move this range and we can switch certain of the location to other cities, and also can zoom in, zoom out to see different distance, what can we got. And once this task decide to click on the task, and we can see here is the details about this task, and we can just follow it or make an offer. And also we can have some comments here. And we already have an offer here. So with this budget, we can take it as a reference to make our offer. We can say 300 or other price you want and send any message to the client. I think we have an offer here. We can continue our task. So on the client side, we can find this task. And we can decide to accept it or reject it. And now we can accept it. And on our tasker side, we will receive the email, like what we just see. And when we want to complete this task, we can just go into the client side dashboard and click on the task and we complete. And we can see the payment information here, and we type in our credit card information. And here we use the third-party API with the Lambda, AWS Lambda to complete this transaction. And after that, we can just rate this task with any comments you want. And also, we use another Lambda function in our profile. So for this user, we can switch the avatar to other picture. So we open the picture and I crop it and wait for a second. And here is our new avatar. And next, I will hand it over to our colleague Colin to show you our tech stack.
Okay, thanks, Rex. Hello, everyone. My name is Colin. Today, I would like to introduce the technical stacks we used in our project. In the front-end project, we use React to build for the whole interface. Also, we use Redux in our project to control the data flow. The style components we use in front-end project helps us to build CSS styles. They all requires us having strong knowledge about HTML, CSS, and JavaScript. Next, we use Stripe in our payment process. Also, we use Azure in our front-end project. In the back-end project, we write programs in Java and use the Springboot as the main framework. PostgreSQL is our database. We use the JOT token to enhance our project security. Lambda is the technology that we use to store data like pictures, just like what Rex showed about the avatar. We deploy our project in Amazon Web Service. Now, please let me hand it over to our DevOps teams to show you more details about this. Thank you.
We are Sendgrid. Now please allow me to introduce the deployment part of our project. First, our web application HomePlus was deployed on AWS platform. We use Jenkins as CI/CD tool to implement the pipeline for both front end and the back end. So we can achieve high and better front isolation. Regarding the networking, we created a VPC with 2 private subnets and 2 public subnets, and a gateway for multi-cloud architecture. For the front end, we deployed the networking through S3, CloudFront, and Route 53, and the ACM to grant the certificate to acquire high scalability and performance for the application. For the backend, we Dockerize the backend Java Springboot application and push the image to ECR. Then it will automatically run the tasks on ECS and Fargate for a better managed service, and also can accomplish auto-scaling based on the different application loads. In addition, we use Terraform, the tool to deploy some code services to AWS platform in order to have more stable and constant environments. Monitoring, we design a system by Cloudwatch and Grafana to analyze our system. The next page, please. Yeah, this is a list of our mentors. Well, at the end, I want to say thank you to all my team members. We did awesome jobs here. Wish all the best in the future. And if you have any questions to our team, HomePlus, please come to our room later. Thank you.
Thank you, Team Lifesaver, for performances. Now let's welcome Team 5, Omni, and Team 6, Think More Forum. Please get ready.
Hello everyone, I'm Chris. Thank you for your time to come to this showcase, and we are Team Omni. Our project is an online management platform designed for the employees of GR Academy. Firstly, I will show a short video to briefly start the presentation.
Good evening, everyone. Welcome to attend Project Omni. I'm the team leader, Bob. The Project Omni is a visualized and comprehensive management platform designed for employees of GR Academy. This platform helps authoritative staff to efficiently manage the relevant workshops, timetables of universities, students' information, and leave of absence. The Omni project has been running since last year, and our team took over in January this year on TF. The main service of this project is for GR Academy employees to conduct internal information management. We are very fortunate to have 6 enthusiastic and motivated team members. Also, really thanks to our project manager and someone who helped us. The project is managed by Agile methodology, and every single developer works closely with each other by using the Agile approach via Jira and Gradle. Our developers use Bitbucket as a version control tool to collaboratively work on code. Then let's go demo.
Thank you for watching. Next, let's welcome Eros and Alex to demonstrate more about our project.
Hello, my name is Eros, and it is my great honor to be here to present our project. I'm sure that after watching our video, you probably have a basic understanding of what our project does. So now my teammate Alex and I are going to show you some of our main pages and features that our team developed in the project. The workshop list page is mainly used to manage courses on the different universities. The table now you are watching is all the workshops we created before. After click the Create button, users can type a course name and choose tutors, workshop types, related courses in the university, common state, and the location to this workshop. All this data we just entered will dispatch to Redux and call the backend API to update in the database. Then new data will return to the front end and update the states in the Redux. After that, URL will be redirected and the workshop information can be displayed here. Now you can fill in more details in the following table. The total price will be calculated automatically based on what we type in the unit price and duration. In addition, users can fill in price tag, marketing tag, workshop summary, unique selling points, and some of other details to complete the creation procedure. This information will be generated to the poster at the same time, and it can be downloaded by employees for marketing purpose. Now just simply click Confirm button. The workshop will be created and activated. Back to our workshop list page. This workshop has displayed in the top of the table. You can also edit, assign, copy, and delete to the workshop you selected, which are pretty much similar with CRUD. Now I just quickly go through these features. After I click editing button, I can change the price easily and save it for this workshop. If I click assign button, the workshop will assign to different tutors. So now you will see the tutor name has updated to Richard Yan in the table. If you want to create a new workshop, but it only has some minor difference with one of the existing workshop, a copy function can be applied in this scenario. So we just simply type some information and create it. Lastly, you can delete this workshop. In addition, there are also some small features like filtering time sorter and delete many. Users can delete more than one workshop at the same time by clicking delete many button. Clicking time sorter button can manage order of workshops. Users can get the accurate workshop by filtering either tutor name or start time. For example, I select the Richard Yan, then select year and month. So now you will see the result has been displayed in the table. That's all I would like to present today. Let's welcome Alex to show you more features.
Good evening, ladies and gentlemen. I'm Alex, and in this section, I briefly introduce other parts where we have devoted our efforts. Firstly, the timetable section is a critical part that the user can check, create, and edit the course management. For example, tutorial, assignment, and exam, which are categorized under the corresponding university courses. Firstly, let's create a new tutorial course. Input validations are put into effect. All you need is to click into the university course, click the create button, and then fill in the information and click save. While one of my teammates is demonstrating, I'd like to mention some innovative functions. For example, users can choose this course to be applied to different time periods on different days. In terms of the saving functions, users can choose between the shortcut name, saving stuff, creating another course, or save and exit. This once was simple save button, but after our discussion with BA, this function iterated to the current version. This has reflected our strong strength, capacity, and coding ability. Lastly, if users have mistyped any information, they can choose to edit again or simply delete if the course is no longer needed. On the other hand, similar functions are also created on the other page, like student management and staff day of management. But as the literal meaning, they are for creating and adding student and staff vacation information. That's all for Develops Web Showcase. Next, the efforts for DevOps. Thank you.
Hello, everyone. My name is Sean, the DevOps team leader, and today I'm glad to represent our team, which is Omni DevOps team, include the two DevOps, me and Roger. And next page, please. Just give you a brief introduction about what we've been doing in our project. We began our teamwork together by using AWS IAM user group. For team user permission, we use Bitbucket and the Jira Confluence. For our team coding and team documentation and review, we also use Docker to manage our pipelines and the Jenkins server as a version control tool. So based on Docker, we actually built 3 CI/CD pipelines on our EC2 Jenkins server. We choose AWS for cloud platform because its marketing share is dominating. And in automation, we use Terraform and Bitbucket plugin in Jenkins to achieve our automation for the whole project. not only a single repo. And also for the monitoring method, we use AWS Cloudwatch and Grafana for the incident management and threat testing. And the next page, please. Thank you. And now, if you could see, this is our 3-tier architecture, which also include the 3 CI/CD pipelines. These are the front end and the back end and the Terraform 3 pipelines. I would start to introduce the front end architecture. So after the deployment, we host our static website on the Amazon S3 bucket. We register our domain and host zone in Route 53. Then we use the Amazon Certificate Manager to create a SSL certificate for HTTPS for the encrypted connection. After that, we deploy the CDN and we combine everything together on CloudFront. So now let's move to the backend architecture, and I would introduce Roger as a host in this part. Thank you, Roger.
Thank you, Sean. Hello, everyone. I'm Roger. Let's talk about the backend architecture. From the diagram, we can see that the ECS cluster was created with 2 product subnets, which are separated into 2 availability zones. Then application load balancer was implemented with 2 public subnets to forward front-end traffic from internet to ECS bucket tasks. Finally, Net Gateway was designed to allow bucket tasks to pull image from ECR outside the VPC. We are using Jenkins server for CI/CD pipeline. Front-end pipeline will be triggered when new code merged into master branch. Start with pull new code. Jenkins will then install package, build and test, and if succeeded, push artifacts to S3 bucket, which hosts the front-end website. Similarly, once backend pipeline triggered, new code will be pulled. Secondly, new Docker image will be built, and then Jenkins push new image to AWS ECR. Finally, it updates ECS service to deploy the changes. To help with the high availability of the application, the following components were designed and implemented. For example, the application load balancer routes traffic to different bucket tasks. When one bucket task failed, application load balancer will redirect to another availability one. And about the deployment strategy, we are using ECS growing update deployment time to ensure 0 downtime. The following configurations are designed and implemented to ensure security of the app. For example, for S3 bucket, we block all public access and restrict S3 access only from CloudFront. Let's move on to monitoring. We have applied Grafana integrated with Cloudwatch metrics to monitor the performance of the app and the ECS service utilization and auto-scaling. For example, the right side of the graph shows when high traffic comes at 4 p.m., the ECS CPU utilization jumps to 40%, whereas the number of ECS tasks increases to 4, because we set up ECS auto-scaling policy, which will automatically scaling out based on the CPU utilization. Next, I will give back to Sean to illustrate the Terraform architecture.
Thank you, Roger. By introducing our IAC tool, as mentioned before, we actually use Terraform as our infrastructure management tool. So in our project, Terraform is triggered via Jenkins, and the remote stack file of the Terraform is managed by AWS S3 and DynamoDB. For managing AWS credential when using Terraform, we modify the AWS credentials of AWS CLI under local environment, while we add the environment variables under Jenkins server. Next page, please. So as you could see, this is our Terraform directory structure looks like. These are 3 main folders in our Terraform, include applications folder, CI/CD folder for the Jenkins file, and the modules folder for the CloudFront, S3, and the ECS bucket. What we were trying to do is make everything clear to use and easy to review. And that is all our presentation today. Thank you for listening, and welcome everyone to join our Zoom later. for the detail if you have any questions. Hope to see you later. Thank you.
Thank you, Team Omni. That was good. Now let's welcome our last team, Think More Forum. Thank you.
Hello, everyone. My name is Alan, and we are Team Think More. And let's get started with a short introduction video of our project.
Watching the brief introduction video. We'll now proceed to the presentation to give you a further detailed explanation of our project. So, Think More Forum is a multifunctional, interactive, and mobile-ready discussion platform. It is a place for people to make any kind of discussion where people come together to share their opinions. We have implemented some technologies in the project that might be different as compared to the other groups, such that we have used Node.js, WebSocket, RabbitMQ, and Redux. Before we proceed further, let's go through our website and check out the range of pages we have. This is the home page. As you can see from the layout, all the forum categories groups are placed right in the middle of the page, with the current online user shown on the left and random post example to the right. Next, we have the category page showing an overview of all the posts that are posted in this category. When you click on the individual post, it brings to the page showing the content of the particular post. This is the profile page of the user, and this is the setting page to update any personal information of the user. The final composition is the admin page for administrators to manage the forum. Overall, the 6 pages make up the main structure of our forum. We have also made the UI/UX design of our forum responsive and concise to different browser sizes. Contents are customized based on the screen size to show appropriate data structure accordingly. We have also used the MUI library alongside for our components development. Now we'll talk about the overview of all the functions available. It can be broken into the user side function and the admin side function. For the user side, the function includes browsing information across the various pages, moving the category, post details, and so on. As you can see from the right, the demonstration here on the post pages, you can change the settings such as hiding the cover page of a post, limit the number of posts shown on the page, sorting the posts based on the criteria in an ascending and descending order, clicking into a specific post, or the comments left under the post by the users can be seen. As a user, you can also view people's profile by clicking on any of the avatars you see. It brings you directly to the user's respective profile page. Using the search bar on the home page, you can also browse for users and posts easily by just typing in a few characters and get the results that you're looking for. As you see from the home page previously, the current online users are shown in real time. We use the WebSocket technology to implement this, such that WebSocket makes it possible for the long-lived persistent connection and save the status of current online users into Redux, the in-memory data structure store. Apart from browsing information, the key function of a user also includes creating an account, logging into their respective account. Email validation is also included when a user wishes to update their email or resetting the password. After you become a user, you can change any of your personal information such as username and password in the setting page. Validation is included to check if a username is being taken or if there's a mismatching of password entered. The user can also customize their own profile page with profile image they like. It can be done from the user's profile page. Any image from the local system can be chosen and uploaded. It can also be cropped to the size that you're satisfied with. Next up, this is just a coverage of all the interactive actions available as a user. It covers a wide range from creating a post to setting up certain posts as your favorite one, leaving comments under people's posts, and following the users that you're interested in. All the actions done are being noticed in real time using the WebSocket technology implemented. Users will receive notification if anyone leaves a comment on their post, likes the post, or becomes a follower. The number of notifications is being updated in real time too. That covers all of the user-side functions, and we'll now move on to the functions available as an admin user. So as an admin user, you can have one or more out of the 4 types of management roles. The first one is user management, in which an admin user can manage the whole list of users, viewing the details and role accordingly. Content management can be done through editing the details of category available. New categories can be created through a button, prompting admin users to fill out the form and include the details for new category. Title and description of the current category can also be changed, and swapping the sequence of categories in a different order. Admin can also hide a certain post or pinning the post to the top of the page. Posts that are hidden can no longer be seen by any other users. Role management system is when admin can revoke any users from the current level of permission or assign them to other levels. Permission levels includes all the basic functionalities such as whether a user can create a post a comment, or upload an image. Another interesting function is where admin can customize the footer of the page based on their preference. Admin can update the current footer with any content that they wish to display. So that concludes all of the functions that are available on the forum, and we will now move on to discuss the technology that we have chosen to use in this project. So we'll start off with the front-end technologies such as the Material UI library, Typescript, Next.js, WebSocket, Format, Redux, JEST testing library, and ESLint. We have chosen to use Next.js with the first reason being Next.js is able to enables incremental static generation, where static generation is used on per page basis. For example, we use the ISR for the homepage and post page, which allows the update for these 2 pages without needing to rebuild the entire site. It is a famous framework to build super fast and SEO efficient websites. On the backend, we have Springboot, Docker, Midnight, PostgreSQL as a primary database, Redux, RabbitMQ, Flyway, and Swagger. We have combined the use of Spring Security and Redux to enable the exchange and storing of real and fake JWT token. This can increase the user information security level as the data encoded in JWT will not be exposed. The overview of infrastructure of a project can be summarized here. We begin from the bottom left, which is the Jira software we have used as our main collaborative tools, which implemented the Agile methodology as part of our project. Front end is being coded with Next.js technology, while backend with Springboot. CI/CD pipeline is being triggered by GitHub action for the backend, and Versa does the automatic deployment for the front end. The backend is containerized on AWS ECR and AWS ECS using Docker, with RabbitMQ for the email delivery, asynchronous email delivery, PostgreSQL as a primary database, Redis as a cache server, and the front end and backend communicate mainly via the RESTful API with the online users and the real-time notifications using the WebSocket. In addition, there's an object storage server using the min.io and the reverse proxy using the Nginx to configure the HTTP SSL certification. Server data is collected using Cloudwatch and Prometheus, and then graphically displayed using Grafana. That is everything from our team. Thank you for listening, and we hope to see you later to discuss further details of our forum. Thank you.
Thank you, Team Think More Forum. Well, now all the team have finished their presentations. Thank all of you. Thank you for your wonderful performances, and thank to all of our guests for watching and listening. Now let's take a short break, or from now on, all of our honored guests can enter the team breakout rooms and get to know the candidates of your interest better. If you have any question, please do not hesitate to talk to any of the characters named JR staff. They will help you to get to the place you want to go. And our teams, now please enter your team breakout rooms.
So Melissa, like I said, I really enjoyed your presentation, but your role on the project was in which area?
Yeah, so similar, like actually we started the project like working together on the back end.
WebSocket part, it was done by me.
Yeah, so like actually like everyone together work on the back end together, like doing all the APIs, like so we spread into, so one person take like the post, like example the settings page, I do the login API, so we finish up all the APIs at the back end, and then we move on to the front end. So like front end I was like in charge like was involved in during some of the login, user login, and then as well as like the personal setting pages to change the username, the password, and so on. Yeah. So we're basically involved, like equally involved in like the backend together. We kind of do the backend together and then we move on to the front end to do the UI, to the design, the functionalities. Yep.
Oh, okay, right. I see. So
yeah.
You actually, like what you said in the beginning, you actually did divide out the work evenly across the front end.
So because the project we actually started doing from the backend first. So from the backend, we actually try to finish up all the APIs, all the the database, and then set up all the creating all the different tables, like what kind of tables we want, and then what's the API links. And then we actually continue to further to add more onto it. But then we basically design the rough, the structure of it, and then we move on to the front end. And then as we go, if there's more API needed, we actually do it, add it to the backend. So we did the backend and then tried out on the Swagger, etc. And then we move on to the front end. Yeah.
Broad set of skills that I constantly face new challenges, like how to troubleshoot, how to find, how to figure out what's wrong with this, because not a lot of problems show at the surface. So I have to dig in a little bit further, and there's not a lot of solutions currently online, like on Stack Overflow or something. So I constantly having to try different things and see which one works and what didn't work, and that's like the biggest challenge for me. Yeah.
Okay, very interesting. And what led you to pick the stack that you were using?
The DevOps.
Yep.
AWS, it's very. I was just thinking that AWS is one of the biggest platform, and definitely a lot of things used. So we did just choose one because it has. We actually try Agile as well, but ended up the very simple reason is we didn't. Things didn't work with Agile DevOps, and things work better on code pipeline. So that's why we ended up having the whole thing on AWS. That's the very simple question. We didn't want to waste too much on something that's not working out great. So yeah. At first we tried Jenkins as well because it's quite versatile. They can use on different platforms, but ended up to save time because we only have less than 2 months to for our DevOps to do the whole project. That's why we would try to save time on the pipeline and do more things later, and then maybe we can come back if we have time to do more practice on that. So that's very simple. That's why we choose AWS, but it did turn out great because it has a very comprehensive tools that we can use, from the root, from getting all distributions from CloudFront or Route 53, and then ECSS, that's it has everything that we needed. And most of the tools, they will have the equivalent on the other cloud platform as well. So once we know how to do things on AWS, we can probably convert it to a different cloud.
The front end isn't there, right?
Yeah.
So how did you decide what functionalities you need to build for your backend API in order to actually make that future need of the front end?
I think sometimes we just build a small a button. For example, we do the pagination. We just do a simple a button to click next page. Then we will see if there's any response from the backend. I mean, if the backend already successfully did that. Yeah.
Because so backend. Yeah, sorry.
But that's the pagination, right? So I think it's Alex, you mentioned, for example, you want to have the create workshop, delete workshop, update workshop, etc., right? But I'm just kind of thinking how did you work out that those were the API codes that you need to create when the front end isn't there?
Because we need to allow all the required from the BA, just like our team. We need to know that. We need to
know where the database we need to using the different data to show in the page, show to the front end.
Right, so the BA gave you a list of requirements about this is what, okay, so all right, and then you work out a bit of a design and a plan and then start building.
Then we just borrow the order requirement from the BA's requirement.
Okay. Yeah, and in terms of the AWS tech stack, that was ECS, Fargate?
Yeah, ECS, Fargate.
Okay.
Yeah, so for the data, I just tell me your answer is we use the fake data to do the test, and the data, all the data is just stored in the MongoDB. And we use a Postman after to test after we finish write the API. And the real data we can't get real data because it's in all G academics share the same backend system, the Keystone, and we just can use fake data. And we are going to do the pull request if it's merged, and the senior will test whether it's okay to do it. So I'm not sure whether it's good answer.
Okay, that's good. Yeah. So, but I'm not that technical deep into.
Our academy graduates, Lawrence and Stephen from the team. So, and Fiona is, I believe, one of the instructors. So she's invited us in tonight because as a health tech company, we're scaling quite rapidly. So we're always looking for people to join our team across the engineering team. But as I said, Eduardo's just walked into the room, so I'm going to let him pick up the conversation potentially. I'm sure he's got some more questions for you guys.
Yeah, nice to meet you guys. I'm curious to understand like what are the biggest challenges that you guys faced during like the implementation of this project?
So I think the big problem is that we don't have any designer or BA, business analysis. So in the beginning, we were struggling which project or any ideas to do. In the end, we just choose the one that we trying to mimic on. So when we got through it, we started to develop it. And on the technical side, we think that we need some special functions like uploading the avatar or connect with the payment API. So we need to overcome the technical issues that we have never learned before. And that's how we start to do some research about what we need, what function we need, and we do research, and we're trying to look up everything and everywhere on the internet to learn about it and start to practice it, to deploy it on the AWS. So yeah, I think that's the most difficult part for us to have a new idea, and we need to transfer it to realize it as we want.
Decide what to do, then assign to each team member to develop. Is that the question you want to ask?
Yeah. So for example, when some requirements maybe not correct in the G1, so someone.
I understand that, but like, how do you differentiate yourself from like the existing tools, like maybe Seek, LinkedIn? What are you trying to do different than?
Actually, basically, for each company which you have already signed up for our system, you, as a company admin, you can create your own assessment, and you can have your own like assessment list, and you can add on more things into it and send it the assessment link to the candidate.
Okay. What are the biggest? Go ahead. Sorry.
Sorry, I mean, just now we mentioned LinkedIn. So on LinkedIn, as far as a user, a normal user, there's no function like sending out the assessment question side. or probably as a company account, I'm not sure whether LinkedIn can provide this kind of service, but yeah, this is kind of an advantage or difference of our platform. Yes.
Okay, what are the biggest challenges that you guys faced during the implementation of this project?
Yeah, so my name is Jan. So I'm focused on the infrastructure side. So as DevOps engineer, and deploy the application to we have used the AWS platform as a cloud platform. So we deployed our application there, our platform there. So let's say the biggest later on, of course, our developers will explain a little bit on the development cycle kinds of challenges or difficulties. But from the DevOps or cloud engineering side, I would say the biggest difficulty I found is you need to find the most cost competitive solutions as a startup. As a at the early stage of the development, you cannot risk of spending to have a big billing staff at the development stage. So that's why when you design or when we design the solution or the platform or the infrastructure on the cloud, we need to compare on the cost basis. So what will be the best? You can deploy for example, deploy the